evening, everybody. Where did we stop in the last class? Types of some terms related to convex mirrors, right? Concave mirror. Okay. I had covered the image formation, real image formation. Sure. Yes, we discussed about types of image, real image and virtual image. We'll repeat that again. So can anybody explain me when real image formation takes place and when virtual image formation takes place?
The real image formed in the plane surface and virtual image formed on an uneven surface.
Say that again, please. I could not hear you properly.
So real image forms on a plane surface and virtual image form on an uneven surface.
No. Did I say that?
When the image is formed on screen, that is
real image can be obtained on screen, but what is the technical requirement for real image formation? Where does it form? Anybody? Reflection. When two rays meet after reflection at a point, that's where the real image forms. Okay, and obviously it is inverted. And what about virtual image? Appear to me after reflection. That's very important. Okay. So today I'll start with image formation by concave mirrors for various object positions. So what are the object positions? Let us understand that. Serial number, object position, then image position, size of the image, and nature of it. This is what we will summarize. Okay. So the first object position is at infinity, where the image will be formed when the object is at infinity. Right? Infinity is the sleeping eight. Right? Infinity means very far away. So the first case is object at infinity. Okay. So mirror is like this because it is concave, right? So the first step is we'll mark the pole. Then we'll mark the center of the sphere. Okay, and then we draw the straight line joining C and E. This is the first step we have to do. Then where is the object? Object is at infinity. So it is very far away. So when the object is very far away, the rays coming from the object, like reflected rays coming from the object, will be parallel to the principal axis. We also can mark the midpoint of CMP and call it focus. Now I had explained, whenever the ray is incident parallel to the principal axis, from where will it return after reflection? Focus. Okay. So you will draw this line. Right. And you will mark the reflected direction. Very important. Incident direction towards the mirror, reflected direction away from it. What is the rule to draw the reflected ray? What is the law of reflection? Yes, angle I should be equal to angle R. How do we verify that? So, what is the normal on at this point? Yeah, radius of curvature. Center of curvature is the point. So, radius at this point from C. Okay. Now you can very well see that yes, it is I and this is R. So when I construct this, I would see that it would pass through focus. It would any parallel ray to principal axis would always pass through the midpoint, which we call focus. So we need at least two rays, right? So even with this, if the ray is incident along the normal, now this is normal only. Principal axis is nothing but normal at pole. So this ray would come back. So where the two reflected rays are meeting here. But anyway, I would take one more ray parallel to the principal axis. And obviously that would also pass through focus. Okay. So since the rays are waiting at focus, what is the image position? Focus. What is the size of image? Point size or highly diminished. We say highly diminished. Okay. What is the nature of image? Real or virtual?
Real.
So you would say real and inverted. Okay. So this is the first observation. So everybody understands what we discussed here. Okay. Now, second object. Yes. So what we will do is we will bring the object close to the mirror. Right? So next position is beyond C. Why are we saying even though it is going towards C? Why are we saying beyond C? Because we measure distances from pole. So first comes C and then beyond C. Okay. So the second object position is beyond C. Beyond center of curvature. So how do we draw the ray diagram? Again, we start with drawing the mirror, pole, center of curvature, principal axis. This is repetitive process. Then I am keeping the object over here, beyond C. Let us say I am naming the object as AB. This is my object. So what I will do is I take two rays from the top of the object because I need the two reflected rays to meet somewhere to be able to know where the image will be formed. And I'll also mark the midpoint of CMP as F. Okay. So the first ray parallel to principal axis. Direction. After reflection, it should pass through focus. Which second ray I can take? I can take through focus and coming back, or I can take C and it will come back along the same line. So, and the third one I can take through pole and then equal angle of reflection. Okay, so I have many choices. So convenient would be to take C in this case. Right? So now C, any ray passing along C would fall at the normal at this point. So it would return from the same path. Because angle of incidence is 0, angle of reflection is 0 along the normal, right? So where are the two reflected rays meeting? Here. Yeah. So the image will be formed between C and F. I write A dash. Right. So image is between. Yeah. What is the nature of the image? Yeah, diminished. So we say diminished. So it is not highly diminished. This time it is diminished. Okay. Again, real and inverted. Okay. So, any difficulty in understanding this? So, I am going to erase it. You all want to draw it quickly? So, draw it quickly. It is the first diagram. Okay, what should be the next object position? So beyond C say at C now, right? So the object is going closer to the mirror. So now at C. At C. So then, oh, I erased it. Everybody had drawn the diagram. Okay. Object at C. So again, same thing. First the mirror, pole, C, and the straight line, which is principal axis. Now mark the midpoint. When the object is at C, so first we'll take straight line parallel, which will return from focus. What about the second line? So now we'll take it passing through focus. So any line which passes through focus, right, will return parallel to principal axis. Explain it a little bit. So I know that the image size should be same. Okay. This is what it will. So this is A dash, right? This is all. So what we are getting now, image is at C and it is same size. Real and input. So can you see the pattern as the object is approaching the glass, right? Where is the image position? The first image was at focus. Now the image is going away from the glass, right? It is moving away from the glass. First at focus, then between C and then now it is. So object is traveling in this direction, right? And image is traveling in this direction. Then initially image was point size, now its size is increasing. Okay, so this is how you can remember. So you cannot go wrong. So for any object position, if you remember what are the object position, then first is focus, then it will be between C and F at C. Now you can predict when the object is between C and F, where should be the image now? Yes. Okay. So not easy, not difficult to remember. So when the object is now will be towards the glass, so it will be C and F. Where should be the image? Image had already reached C, so it will go ahead. And its size is going on continuously increasing. So now you will get first magnified image. Okay, and last. So it's very difficult, easy to predict. So beyond C, we'll see that. So fourth. What is the object position? Object between C and F. So then you have C, now the principal axis. You have F here. So object between C and F. So in this case, what is convenient? So this is by default. This is the most convenient line. Parallel. Now, which would be the next convenient line to take? So either you take from focus and return, or you can take from along C, right? Which one is convenient? I think focus, right? So take it from focus. Okay. And then the reflected light will travel this way. Where is it forming? Beyond C. This is what we had predicted. Right? So this is A, B. And where is our image? A dash, A dash. Right. So where is the image found? Beyond C. So it is enlarged. Real. So I hope no difficulty. Can you try the next one? So what is the object position of at F? Try yeah, at F. So it will be infinity. So it will be highly enlarged. enlarged, yeah. Real and inverted. You will draw the diagram and then I will correct it. If there is any mistake. So if you don't draw the directions of arrow of incident and reflected light, the diagram will not be considered to be complete. Okay, so please keep this in mind. Can I erase this image? Has anybody drawn it?
Yes.
Who has drawn? Correct. Can you, is there any other ray which you can consider for this?
So take it to focus. But it will, we have to use the dotted line.
You have taken it to focus, right? One side.
For the center of the.
Center. Focus is already taken. Yeah, so both rays will give you the same result. Yeah. Anybody else has completed? That yeah, almost everybody completed. So everybody has got it. So I'll draw it still. Okay. So this is that focus, object and focus. Right, so this is C, E. So where is the object now? Object is at focus. I'm keeping it here. One is parallel to principal axis and it goes right. Other way, I can take either incident at principal and then it will be reflected at equal angle, whatever is incident, or I can take it along the center of curvature. So whenever I take a ray along center of curvature, first draw it through a dotted line. Okay. Then how the ray diagram will be completed? The ray travels along normal. That is the incident ray. Then the reflected ray will pass through this. Now complete. And make sure that the rays are parallel. It should look parallel. Yes.
Sir, then how will the examiner know that we had drawn the dotted line?
How would the
Examiner know that we had drawn the dotted lines?
no, it's not for the examiner, it is for your own convenience. Because if you draw the dotted line, you know that this is the path. Now I'll just convert the dotted into solid. Or anything, you can draw a solid line also. Now that you know this point, these 2 points, you can keep the scale at these 2 points, C and the object top position. And draw a straight line also. But do not forget to draw this arrow sequence. First incident direction, and then the reflected direction. And that's where it should go towards infinity. So where is the image? At infinity. So if it is at infinity, this is the object size. Let us say F, at F, we are calling it as A. So A will be where? I mean, very big, right? These parallel rays are supposed to meet at infinity, so highly enlarged. So this is the order. last one, and it is very important. Generally asked in exam. So what is the last position?
Between F and P.
Between F and P. So what do you expect? The image. This has come here, so image will go further away. It's behind them. Yeah. So image position is behind mirror. Right? This is an exception to this pattern. And the nature also changes. It is enlarged. Yeah. And now virtual eminent. Okay, it is virtual eminent. Let us see how it is. So you have. So anybody has any question in this diagram? No? Everyone for this one. Okay, let me go ahead. Okay. So, let us say this is our object now. Okay, so the first reflected ray would pass through focus. Okay. Second one you can take through center of curvature. How do you? So are these rays parallel? They are like appearing to be diverging. So the observer here would feel that these rays are coming from somewhere and extended backwards. These two rays will meet somewhere, right? Wherever these two rays meet, that's where the somebody observing from this side would feel that these rays are actually coming from this point. So the image will be not there. So this is A, B, this is A dash, B dash. Right? So this is all this. Any explanation required here? This is a that object position, object at object between F and P. That question for examples. Okay, object between F and P. So image is virtual element. Where would you use this situation in daily life?
So it's dentist.
Yes. Dentist would use a, so you would have seen, have anyone visited a dentist? Yeah. So you have spatula kind of a thing, spoon kind of a thing. On top of it, a small circular concave mirror is there. So a dentist would not have the view of your upper teeth. So you would put that mirror and you will see the image of that. If there is any cavity, you can very clearly see it. Right? Dentists and also shaving mirrors. Right? So you can see the face like being magnified. So where you have to position the mirror, your face or the object between F and P. Okay. All right. So next topic was that only. Uses of concave mirror. Can you erase this table? Have you written it? Uses of concave. So where can it be used? So it can be used in torches, searchlight, headlight, or vehicle. Headlight or vehicle. Right. Oh, so you need a good parallel beam coming out from torch, right? So how will you get it? So you have a concave mirror. So you would position the source of light at the focus, right? So light would fall whenever the light would fall on the mirror from focus, right? It will be parallel to the principal axis. That's it. Strong parallel beam will be produced in this situation. So all vehicle lights are now used this situation. Okay. The source of light is positioned, the bulb is actually mounted at the focus of the mirror. Yes.
Sir, but it still seems to that diverge, increase the.
What is diverging?
In the headlights, it seems to diverge.
Yeah, because of the imperfection. If it is a laser light, the divergence will be less. Because now we are teaching you that light travels in straight ray. In lower standards, we teach you that. But there is something called as diffraction of light. Light has a phenomenon of bending at the corners. So it is because of that. But that is in higher standard. Okay? So because of that. Second, it is used by dentists or as a saving mirror. What is the situation for that? This diagram. Okay, when you place the object between focus and pole. Third situation is solar devices, solar heating devices. So, as solar concentrator. So what happens is, suppose you have a and the sunlight is falling on it. So this falling. Right, let us say these three lights are falling parallel. So obviously, this is the principal axis. All this light will basically meet somewhere on the focal plane. Right. The third one also will travel like this. Okay, so in the focal plane somewhere. Okay. So here what we will do is, so all this light which is coming from sun is concentrated here. So we will put some device which will absorb that heat. So that device will have a water flow inside it. So the water flowing inside that will get converted into steam. And then we will guide that steam wherever the food to be cooked is kept. So the steam heat will be transferred to the food content, and then we can use that heat as heat for cooking purpose or any other purpose, right? So this is how concave mirror is used as solar concentrate. So you can heat, you can have solar water in the, like that. So application is your call. You can design a system. So there could be many applications which can be built, like solar water heater. Or cooking purpose. Right? Anything. I have drawn the diagram just to explain. Even if you just write words, it is enough. Ray diagram not expected for uses of concave. I will be proceeding now for image formation by convex mirrors. First. So is anything wrong with the diagrams you have drawn? So I've just violated the convention. All the incident rays should be from left to right. Right? But since I can hold the torch any issue, so this is also. So for learning purpose, all the ray diagrams should be left to right. You could just take a 180-degree reflection of that and you can draw those. Right? So this is okay. Next is image formation by convex mirror. So for various object positions. So what is a convex mirror? It is a reflecting surface is curved outward. Everybody ready? Now where is the center of curvature for this? Right side. No? This here center will be on the right side. So where is its focus? On the right side. Right. So we'll draw a straight line that will pass through pole and center of curvature like that. It should be a straight line. That's it. So for convex mirror, you can have only two object positions, right? Because all the points are on the right side. So one is at infinity, another is beyond pole. Beyond pole. Only point is pole here. So at infinity and beyond pole. Okay. So first is at infinity, object at infinity. So when the object is at infinity, we only show straight line. Right? So then it will reflect. Which direction will it reflect? For that, I need to know the normal. So normal is just draw this line. Okay. So now I am getting the angle of incidence. Even without normal, I can draw this line along focus, right? Okay, if I don't want to draw normal, I can draw this reflected ray along focus, like this. Okay, and then what will I do? I will extend this line till focus. This is what I will do. Right. Now, where will my image form? At focus. focus. So for that, in this case, I will take another line, another ray. So then this would reflect in this direction. The reflected light. Right? Obviously, like that. When somebody sees from this side, you would feel that his rays are diverging from focus. So what is the image position? Image position at focus. For object at infinity, image position at focus. Size highly diminished. Okay. Nature, yes. Okay, it is virtual and correct. If you want, you can draw this line also, a normal. So the second object position for convex mirror is beyond pole. So it's beyond pole. Okay. So again, the mirror object A. First would be parallel to principal axis, and it will reflect this direction. So right. The second ray you can take along C. Right. So if it is along the normal incident ray, it will return from here. Second ray we saw, we took it along the normal. So it will travel here and it will reflect from this mirror along away from C. So that people in this direction would feel that the reflected ray is diverging from this point. Okay, the reflected ray is diverging from this point. This is what observer feels. So A dash, B dash. So here you have to say image position at focus behind mirror, you should write. Behind mirror. Okay, it's behind mirror. Here also. What is the image position? Between P and F behind mirror. Between P and F behind. size is diminished. Right? Nature. Right. So I hope no difficulty. Okay. Let us discuss the uses of convex mirrors. Anybody has any question here before we discuss the uses? No. So, what is the use of convex mirror? Yeah, rear view mirror of the vehicle. Why do we use this mirror as a rear view?
You can see it is diverging. So for
It is.
it's diverging. So for wider field of view.
Yes, one is wider field of view. Second is the images are upright, so driver won't be confused. Although he has a wider field of view, so he would be able to see a lot of traffic behind him. Right? At the same time, it is upright, so you will have clarity. Okay. So these are the reasons. Hence, wider field of view. Although the images are short, it's not magnified, but yes. Right.
That's why it says objects in the mirror are closer than the other.
Yes, it's closer than they appear because it looks small to you, so you're really not in a position to judge how far away it is from you. Right? And it is the object is constantly approaching you. So when you saw last and you drove ahead, and then again when you came back, it has come very close to you. And that's when you learn driving. There are certain blind spots, right? When you're driving, so there are certain blind spots. This object is behind you, but you will not see it in your rear view mirror. So that's when you have to do shoulder check. If it is not in the mirror, it has not crossed you. Where is the object gone? So it is right parallel to your shoulder. That's when it doesn't appear in the rear. So you have to. So those things you will learn in driving. Okay. So, still time? Yeah, 10. Okay. Lot of time actually. But you might be seeing your elder brothers or parents driving. So, I don't know, how many of you are curious to learn driving fast? Really? Okay, good. You all ride bicycles? So first thing is ride bicycle. You want to learn that. There are many people who sit at the steering wheel and then they have no sense, road sense. So bicycle riders will get to learn. The two-wheelers also will pick up to two-wheeler riding past and the car. Okay, good. Two-wheeler, everybody, to start with? Huh? No? Why?
With the car.
Why? Parents will not allow or you are not interested? Come on.
It's dangerous.
What is dangerous? I mean, you
No,
know the
like,
basic-
in the village, one accident happened.
So that phobia set. On roads, people die. So do we stop coming out on the road? That's no. I'm sure you'll be able to convince your parents, but just be responsible. Right? That's it. You don't stop things because somebody else suffered majorly. Right? So since there is very less time left, so I thought, so any questions on what we covered today? So in the next class, I'll cover the sign conventions, magnification, right? And error formula. Okay. And possibly we'll also start image formation by lens. Refraction, what is refraction, image formation. Is this chapter completed in your schools? The school itself is not started or this chapter? School is. That's fine, but some schools are like quite ahead. I don't know why are they doing it. So your school, like, you know, right? They are racing. Okay. Good. So that's good. And nothing wrong. Like I mean, thank God so far I'm alive. I'm driving two-wheeler. I'm driving car also, but then I've ridden from here till Varanasi and came back.
But my mom is also a high school teacher, so she has.
High speed teacher.
High school teacher.
High school teacher.
So she has seen her students falling and very well.
Because they are not following the rules. That's why. I mean, when you should break, when you should not, how you should decide, should we stop breaking or not.
So first of all, they go with very high speed.
Yeah, because speed thrills and young hormonal that rush is there. So everything is like speed. That's not driving is not about speed. But it depends at what age you are. So initial excitement, you have to contain your excitement. Then you can enjoy the ride for longer duration. Right? So it's when it slips, no, whenever the bike or car, anything, when it starts slipping, then you cannot control it. So you have to avoid slipping at any cost, because if you are walking also, when you slip, you can't control yourself. Understand? So you have to avoid slipping at any cost. So what is the way? Reduce the speed. Okay, reduce the speed, slow down. If there is any slippery surface, you contain within yourself, right? That's all it is. And don't lean too much ahead of one. Center of gravity, have you learned about it? So it has got to do with center of gravity. All right, so see you in the next class. Time was still 5 minutes.
5 minutes.
Yeah, that's not, no, it's not okay. I mean, I was wondering. So shall I start sign convention? In 5 minutes we can do sign convention. I thought it's till 20. Come on, get back. It has happened before also. I forgot the time that it will end at 35. Okay, so sign convention. Sign convention is what is the sign of the distance measured from the mirror? Okay. 5 minutes. I know it's difficult to get back to the rhythm once you've decided, okay, everything is closed. Okay, so suppose you have a mirror like this. It does not matter whether it is concave or convex. And we know that this is pole and you have center of curvature, this is focus, right? So you are already aware about Cartesian coordinate system, right?
Yes.
Okay. Same sign conventions apply here. What is origin in case of Cartesian coordinate system? Is pole in this case. Okay. So in this system, all the incident lights are in this direction, left to right. Incident light direction. Direction. Left to right. All the distances are measured from pole. So distances to the left are negative, just like Cartesian sign convention. Left of the origin is negative, right? So all distances are measured from pole, and then towards pole distances are positive. This is positive. Okay. But where will you measure positive distances? Here, right side of the pole. Anything, any distance which is right side of the pole will be positive. Left side will be always negative. Okay. Then any distance above the principal axis would be positive. Like this is positive y-axis. And any length below the principal axis would be negative. This is the sign convention. Right? So with this sign convention, now let us say object is kept here. Let us say this is the object position. Let us say AB. So what is the object sign? Yeah. So this will be minus. Okay. Object will be negative because we are measuring the distance from here. Now, if the object was between F and P, right? Now, object is here beyond C. Where is the image between C and F? What will be image? That also negative. Okay. So, are you with me? Because the object was beyond C, where would the image form? Between C and F. We just did. So, the image distance also would be negative, right? And what about the focus? Focal length? That also will be negative for a concave mirror because it is on the left. So for convex, what is the situation here in this case? This is minus u. So object is always negative because it is always kept in the left side. What about image? Positive. Positive. This is image. Okay. What about focus? Positive. So clear? Focus will be positive. Okay. So by convention, for convex mirror, focal length is always positive, right? And for concave mirror, focal length is always negative. So it is true for lenses. Convex lens would be positive, concave lens would be negative. I will cover that when we reach that. Okay.
Now the